In this video, I'm going to explain the comparisons of variances in simple random sampling and proportional allocation in stratified random sampling. Okay, so in this video, what we are going to study is about the comparison of variances in simple random sampling. I use SRS for simple random sampling, and proportional allocation in stratified random sampling okay. So basically what I'm going to do in this video is I'm going to derive the relationship between the variances in simple random sampling and proportional allocation in stratified random sampling. Okay, so basically what we have studied is variance of x bar at simple random sampling is greater than variance of x bar stratified at proportional allocation, right? And then greater than or greater than equal to variance of x bar stratified at Newman allocation, right? Newman allocation, and this Newman allocation will be approximately equal to variance of x bar stratified at proportional, optimum allocation, right? So we have studied optimum allocation, right? So I saw a past paper question where they have asked to find out the variance using the optimum allocation, but they haven't given the cost, right? So in that scenario we have to find out the Newman allocation variance and then compare, right? So this is what we have studied. Anyhow, in this video I'm going to explain only this part. Okay, so we will just focus only to derive this inequality. Okay, so what we have studied is we have studied equations for variance of x bar in simple random sampling, and we have separately studied equations for variance in x bar, variance of x bar at stratified random sampling under proportional allocation, right? So under probability sampling techniques, we first studied about simple random sampling, then we have studied stratified random sampling, we have studied cluster sampling, and we have studied systematic sampling also. And under stratified random sampling, we have studied about the allocations, right? So equal allocation, then we have studied equal allocation, we have studied about equal allocation, then we have studied about proportional allocation, then we have studied about Newman allocation, and optimum allocation, right? So these things we have studied, and for each type of allocation and for each type of sampling techniques we have studied a lot of equations. So now what I am going to do is in order to derive this inequality, let me first write down the equations that we have studied for variance of x bar in simple random sampling. So variance of x bar in simple random sampling is equal to s squared in n minus n divided by n, right? So let me take this as the first equation. And now we have studied about the variance of x bar in stratified random sampling under proportional allocation also. So for that we studied this equation, x bar stratified at proportional allocation, right? Proportional allocation is equal to n minus n divided by n summation of I is equal to 1 to k, right? So 1 to k mean number of stratums, right? So k is here number of stratums, and wi si squared, okay, wi si squared, where wi is equal to ni divided by n. N means the population size, and this ni mean stratum size, right? Stratum size. So the stratum means the entire population. A heterogeneous population is divided into a lot of homogeneous divisions. So each division is called stratum. right? Stratum, and the plural of stratum is strata, right? So those are basic things, and this is population size. Population size. Okay. Right. Now you see we have to develop a relationship between these two variances, but here we have S, but here we have SI. Okay. So what I am going to start with is, we have studied an equation for this one. S square is equal to 1 divided by n minus 1 summation I is equal to 1 to k, summation j is equal to 1 to ni, xij minus x bar. This x bar is the stratum mean, right? So stratum mean square, right? So this is what we have studied, and from this equation we are going to develop a relationship between these two variances, right? So in order to understand this proof, let me explain you some properties regarding this summation notation, right? So since we are going to work with summation, you should have some prerequisite knowledge about this summation. So summation, right? So let me first explain the concept of summation here. Okay. Right. So let me take some space. I will just explain here, right? Okay. Wait. Okay. So summation, so you should be familiar about you should be familiar with this notation. This is summation, right? So this is called summation. Summation means simply addition, right? So addition. So now the notation summation means, for example, if we have summation, okay, if we have something called summation, I is equal to 1 to n 1 to n xi. So this is equal to x1 plus x2, because this is called index of summation, right? So we call this I as index of summation, and this n is called the upper limit of summation, right? So upper limit of summation, up to which point we are going to sum this function falling within this summation notation, right? So x1 plus x2 plus x3 up to we have xn terms, right? So we have n terms here, right? So these n terms are multiplied here. So this can be again written as, so as individual addition of each term when we substitute the values for I from 1 to n. Otherwise we can write this way also. No, okay, so I will just explain this one later. So for example, if we have something called like this, summation I is equal to 1 to n, but if we add a constant, right? So c represents a constant, right? So this is equal to, now we do not have any I here, so this constant is independent of this index of summation. So this means this simply means c1 is added, if this means c is added n times, c plus up to n times. So this will be equal to n into c. For example, if I take summation I is equal to 1 to n, whatever this is 2 means, so this will be equal to 2n, right? And if I have xi, right? So I have already explained this one. And for example, if we have something like this, summation I is equal to 1 to n cxi, right? So this can be written as c into summation I is equal to n to 1 to n xi. So within a function, if we have any constant, so we can take the constant outside of the summation. Okay, so that is also you should know. And what else? For example, let's say we have something like this. Okay, now I'm going to explain you about double summation. Now we have x is equal summation I is equal to 1 to n or 1 to n or 1 to k. For example, here we will take 1 to k, and summation j, another index of summation, right? This comes till n, right? So we have xi n yj, right? So if we want to deal with this kind of double summation, this is like this, right? So now if you for example, if you have a calculation like this, I'm just taking an example for making you understand regarding this regarding the procedure of dealing with this double summation. Okay, so for example, what can I tell? Let me take calculation involving parentheses, bracket and braces, right? So now I'm just taking this, okay, 2 plus 3, 5 into 2 plus 3, right? So if I want to okay, for example like this, if I want to simplify this one, if I want to simplify with this one, I have to first work with this parenthesis, right? So this is called parenthesis, this is called bracket, and these are called braces, right? The pair of these the pair of these are called parentheses. I'm sorry, these are called braces, these are called brackets. We may call this as square bracket also, and these are called brackets, but we are used to calling all these symbols as brackets, right? So I don't know, anyhow. So what we will do is we will start from the inner part, right? Inner parenthesis, right? So first we will simplify this, right? So how we will deal with this kind of questions is like we will first work on this one, right? So we will first solve this. So 2 plus 3, right, 5 into this one is equal to 5 plus 1. Again we have to apply Bodmer's rules also. So this will become 2 plus 3, 5 into 5, 25 plus 1 plus 1 plus 1. Here this bracket is there, right? And plus 1, okay, and these braces. Okay, again what we will do, again we will work this square bracket. So it will become 2 plus 3 into 26 plus 1, right? And here we have braces, and this will be equal to like what do you call, first now we have to deal with this, right? So it becomes 2 plus 8 1 7, right? 78 plus 1. So the final answer will be 81 if I am not wrong, right? So you can calculate. So here what I want to tell you is, if you want to do any calculation, you have to involving parentheses and brackets, so you have to start from the inner part. You have to work starting from you have to start working from inner parts. So likewise we have to first do, or we have to consider this inner summation, right? So this inner summation, now you see for this inner summation we have the index j, but this xi, right, this is this I is constant for this one. So what we will do, considering this xi as constant, now we will take this out of the summation. So this will become summation I is equal to 1 to k xi summation j is equal to 1 to n y j, right? Okay, now we have to do this, and then again considering this as a constant, we can take this out. So if I do any example, then you can easily understand, right? So let me erase all these stuffs here. Hope you have understood this calculation. This is very simple. We might have done in our junior grades also, but I just wanted to explain that if we want to do any calculation, we have to start from the inner thing. So we have to work from inside, right? So that is the basic idea that I wanted to tell you. Now if I take an example for this one, so now we have I and j, right? So and xi, right? So let's say summation I is equal to 1 to 3 summation j is equal to 1 to 2 xi y j, right? And for xi and yj we have been given values also, right? So let's assume we have, okay, x1 is equal to 2, x2 is equal to 3, x3 is equal to 4, and y1 is equal to, we have only for 2, no? Y1 is equal to, let's say what do you call 10 and y2 is equal to what shall I take? 5. Okay, 5. Okay, let's try this substitution. So now what I can do is so with regard to this summation, taking this summation, this I is constant because it is for j, so this xi is constant, so I can take this outside. So this can be written as summation I is equal to 1 to 3 xi summation j is equal to 1 to k yj, right? So now we have to deal with this one, right? First we have to deal with this one. So I can write this as summation I is equal to 1 to 3 xi. I am writing as it is. Now I have to just add this yij. So this can be written as y1. I'm sorry. This starting from 2, right? y1 plus y2. So now if I substitute this summation I is equal to 1 to 3 xi instead of this, right? So I'm sorry, I'm writing this here. Okay, so now if I write the value for this here, okay, so if I can write the value for this here, this will be like summation xi for y1 and y2 I know the values 10 and 15, right? So 10 plus 5, so this becomes summation I is equal to 1 to 3. So this is 15, this 15 is constant, so I can take this 15 out, right, out of this summation. So 15 summation I is equal to 1 to 1 to 1 to 1 to 1 to this one, what do you call 3, here 3, no? So x I, so this is equal to 15 into, now if I extend it, or if I expand this summation, this will become x1 plus x2 plus x3, right? So now for x1, x2 and x3 also we have been given values. So 15 times 2 plus 3 plus 4, right? So this will be equal to 15 times 7, 5, 9, right? So the answer would be 5, 4 means 135 if I am not wrong. Anyhow, let me verify the answer with the calculator. 15 times what is this? 15 times 9, right? So this is 9. 15 times 9 is equal to 135. Yes, I am correct. So the answer is, let me write this beautifully here, because this is this is times 9 is equal to 135. So this is how this should be done, right? So so far I have discussed about these things, right? Now what else do you want to know about this summation? I think that's all. That is enough, right? That is enough. You can do this in this way, otherwise you can write this in this way also, right? So if you consider this now summation of, you can try this separately and try this separately. Between this we have multiplication symbol. So now you see this one, some x1 plus x2 plus x3 into y1 plus y2. So this is equal to 2 plus 3 plus 4 into into this one. What is this? 15, right? So if you multiply this also, you will get the same answer, 135. So with this understanding, we will now go to the proof of this one. Let me just erase all this stuff to create some space here. Hope you have understood this summation concept. Right, now let me work on this proof. Okay, so now I am going to introduce this SI to this one, right? So for that, what I am going to do is I am going to consider this equation, right? So taking, so I am going to start my work from this equation, right? So give me a second. Okay, so so what I'm going to write this as, I'm just writing this, I'm just taking this n minus 1 here. So n minus 1 s square is equal to summation I is equal to 1 to k, summation j is equal to 1 to ni. So I'm just taking, or I'm just considering the stratum, right? Stratum means ith stratum, right? So I'm just considering, even if I have k stratum, I'm just considering the ith stratum. Okay, right? Xij minus x bar holding square. Now what I'm going to do is, for the modification of this equation, I'm just going to add the stratum, ith stratum mean into this expression. So I can write this as I is equal to 1 to k, summation j is equal to 1 to ni, xij minus xi bar. So this is what? This is basically the stratified random sampling mean, and this is basically the ith stratum mean, right? So ith stratum mean plus xi bar minus x bar holding square. Now you see, we have already studied, now this is also very important for under summation. You should know this also, right? So for example, if you have summation I is equal to 1 to n, let's say ai plus, I'm sorry, ai squared minus bi squared, I'm sorry, this one, not this one. For example, if we have something like this, summation ai minus bi holding square, now this can be written as summation I is equal to 1 to n. This can be expanded as ai squared minus 2ai bi plus bi squared, right? Now I can distribute this summation to this expression. So this can be written as summation I is equal to 1 to n ai squared minus summation 2 summation ai bi plus summation bi squared, right? So I started from 1 to n, right? So that is obvious. So you should know this also, right? So I just wanted to tell you this. And again, because we are going to apply this method or this idea into this expression also, that's why. Okay, now you see here, I'm going to consider this as A and this as B, right? This as B. So this as B, I'm sorry, not this as B. I'm going to consider this as A and this as B. This is A and this is B. Now A plus B holding squared is equal to A squared plus 2AB plus B squared, right? So now how I can write this expression is like you see here, this can be written as summation I is equal to 1 to k, summation j is equal to 1 to ni. Now this is going to be written as xij minus xi bar holding squared plus, I'm just writing this b squared and b squared term second and this middle term lastly, right? Last. So now this can be written as xi minus x bar holding squared plus 2 into summation, I'm sorry, 2 into this one, I'm sorry. This can be written as 2 into a into b, right? A into b. So a is here, this one, xij minus xi bar into xi bar minus x bar holding square. No, here square will not come. Okay, you have to be very careful while doing these proofs, right? Now I'm just explaining all the steps step by step and explaining the reasons why I am taking every assumption or every decision, right? Now you see this, now I'm going to distribute this double summation to all the expression or all the terms involving in this binomial expression, trinomial expression actually this is, okay, right? So this is summation I is equal to 1 to k, summation j is equal to 1 to ni. This can be written as xij minus xi bar holding squared plus summation I is equal to 1 to k, summation j is equal to 1 to ni, xi minus x bar holding squared, here bar, here also bar, I forgot to put bar here, and where else, that's all. This is this x bar and this is x bar and this is xi bar, okay. This is stratified mean and this is ith strata mean, okay. You should be very careful about those stuff. Now plus 2 summation I is equal to 1 to k, summation j is equal to 1 to ni, xij minus xi bar, xi bar minus x bar, that's all, okay, right? Now I don't need this bracket. Okay, now I'm going to start working on this, okay, right? So if you observe this long expression, don't be afraid of it because this is very simple, okay, right? So now you just consider this one, okay, this one. This is nothing but the population variance of ith stratum. So I can write S I square, ith stratum variance is equal to 1 over ni minus 1 summation I is equal to 1 to ni xij, right? So this means ith what do you call, stratum and jth observation, right? So like that. So xij minus xi bar. So this is what we have learned, square, right? So now you see this, if you look at this one here, this is available, right? So this is available here. Now if you look at this expression, the same expression is written here, okay, the same expression is written here. So instead of this one, what I can write is I can bring this term to this side. So this one, right? So I am writing this one, okay. This one means, let me just copy this. This is equal to now, this is equal to now Si squared n minus ni minus 1, right? So instead of this I can write this one. So this becomes summation I is equal to 1 to k is ni minus 1, yeah, whatever, ni minus 1 in I, not this one, this is not like this, ni minus 1, this is ni minus 1, right? So this minus 1 is not in the subscript of this n, right? Okay, so let me write it clearly. So this becomes ni minus 1 si square, right? So done. Plus now you see this here, I is there, now we have to focus on this summation, right? So for this one this n, now this is something. Now this xi bar, this is basically a constant. Now this xi is independent of this j, so the entire expression is a constant now. This entire expression is constant now. So now if we have something like this, summation I is equal to 1 to k c, so this will be equal to k into c, right? So whatever we have here, so this can be written as, now if we have, now we are just focusing on this, right? So this can be written as summation I is equal to 1 to k ni, because here we have k and we write k, and here we have c, here we write c, right? So likewise here ni is there, and instead of this c we have this one, so ni into xi minus x bar whole thing square. Okay, right. Now let me erase this. Okay, so so far I think you have understood. Now we will go for this one, plus 2 times. Now you see I already explained you summation xi, summation. Okay, now for example if we have something like this, summation something like this. So now if we have something like this, summation I is equal to 1 to n, okay, whatever, summation j is equal to 1 to n xi yi. So for this summation this xi is constant, so we can take this out. So this can be written as summation xi summation yi, right? So likewise we can if you observe this one here, I and j, I term and j terms are here, so this is a variable, we can put values for j here, but this term is constant. I mean, like for this summation this is constant, so I can take this out. So 2 into summation I is equal to 1 to k xi bar, here also bar, right? Here also bar, I forgot, xi bar minus x bar into summation j is equal to 1 to ni, this one xij minus x bar, here x bar, okay, here there is nothing here, x bar, that's all. Okay, so I have just taken this within these 2 summation notations, right? So this has come here, that's all. Okay, right. Now what we'll do is you see this here, this is okay, here this is something we have obtained, right? Okay, now you consider this one, now we know x, if you just look at this one, you look at this one, okay, I'm going to look at this one. Now you see this is something, I'm just going to deal with this summation, right? So now if I write it separately, then you can easily understand. Summation j is equal to 1 to ni. This j, don't confuse with this j, it can be anything. Now I'm just writing I, right? So xij minus x bar. Okay, right. So you see this can be written as summation j is equal to 1 to ni xij minus nx bar minus nx, here there should be xi, right? So I forgot to write I here, there should be I here. Okay, so don't confuse. Okay, so after xij here I is there, here okay, this is converted. Now ij, okay, so there is I, but I already told you there is nothing, but this is I, right? So I haven't deleted this I, here I is there. Okay, you should be very careful. Xi, so xi, now xi bar, right? So you see now xi bar is equal to summation j is equal to 1 to ni xij divided by ni, right? So instead of this one what I can write is okay, so this is not this n, this should be capital Ni, right? So because I was explaining something else here, so this is the capital Ni. So instead of this one I can summation j is equal to 1 to n, I can write xi bar ni, right? So instead of this I am going to substitute this value xi bar ni minus ni x bar xi bar. So basically this is 0, right? So this is 0 because this is equal to 0 means this is 0. If this is 0, the entire terms become 0. The entire terms becomes 0. So we are going to just ignore this one. Okay. So let me erase the unwanted stuff to simplify this calculation. You may feel comfortable then. Okay. So this is not necessary. So I hope you understood how it became 0, right? Okay, so what we have is this, right? So we just want to simplify this. So now we can simplify it easily. Now we are going to take some assumptions, right? So the assumptions are n are too large, right? So in such scenario, if n is too large, then if n is too large, this n minus 1 is approximately equal to n. So I want to write down the assumptions here. Consider n is large and ni is also large, so it becomes like this. Okay, you have to write in words, right? You can just mention that ni and n are too large. So in that scenario, n minus 1 is approximately equal to n. So I can write this is equal to n squared, right? So n squared is equal to again n squared is equal to summation I is equal to 1 to k. This is again ni si squared plus summation I is equal to 1 to k ni xi bar minus x bar holding square. Okay. Now I can divide the entire equation by capital N. So it becomes s squared is equal to summation I is equal to 1 to k ni divided by n si squared plus ni divided by here I forgot to write the summation. So summation I is equal to 1 to k ni divided by n xi bar minus x bar holding square, right? So now we have already taken this ni divided by n is equal to wi, right? So we can just substitute that here, right? So this becomes s squared is equal to summation I is equal to 1 to k wi si squared plus summation I is equal to 1 to k wi xi squared xi bar minus x bar holding square, right? Now what I'm going to take is I'm going to take the equation that I have written over here, right? So let me just copy this. I'm going to just consider this equation. Paste here. So what I know is I can just rewrite this equation like this: variance of x bar simple random sampling. Now my purpose is to bring this variance of x bar stratified at proportional allocation. That's why I have inserted or introduced SI term into this equation, so that I can easily bring variance of x bar stratified at that one, right? Sum is equal to, now I just bring this in here, so it becomes s squared n minus n divided by n, right? N. Now instead of this s squared I can write this formula, okay? So just let me copy that and paste here. So instead of this scared, I'm just writing this over here, right? So don't confuse. Here instead of this scared, I have just written that one. Okay, right. Now you see, this is simply that we have studied variance of x bar simple random sampling is equal to, this is nothing but the equation of variance of x bar stratified under proportional allocation, right? So that is equal to this one. What is this? Variance of x bar stratified at proportional allocation plus this one, summation I is equal to 1 to k wi xi minus x bar holding square. Now you see this one, we have developed an equation with respect to something. But in the equation we have this and this, what we have to compare. Okay. So now you see, for example, by equation mean that is just a comparison, right? So now let's say if we consider this equation, now we will just understand whether this expression is, or whether this term is positive or negative, right? So this is summation. Wi mean ni divided by n. So numbers always positive. And here, right, we don't know whether xi is greater than x bar or not. But even if this one is negative, we have square, so it will always positive. This is positive. The summation of something positive is also positive. So this is always positive, right? This is always positive. So now let's say if this is 5 is equal to 4 plus, let's say, a positive number plus 1, right? So plus 1. So we can tell 5 is less than 4. So we can tell variance of x bars SRS less than variance of, or sometimes that might be equal also. If these terms become 0, then this and this are 0, 5, right? So this and these are 5. So that's why we use this symbol also, right? For example, xi and x in such scenario, this term becomes 0. That's why we compare this, right? We just understand this is mathematics, very simple, right? Now you see variance of x bar stratified at proportional allocation. That's all. The proof is done. Okay, right. So what I wanted to tell you is that's all. We have done this part. That's all, completed. So I hope you enjoyed this video. So if you have understood, or if you have learned something new from this video, just subscribe to my channel, like the video, and share with the friends and colleagues, those who need this video to pass your exam or whatever. So I hope you understood this. Anyhow, I have tried my level best to explain this proof, because I also struggled because I didn't understand this, but then I just went through the proof step by step, applying some mathematical knowledge that I had, and then especially for biological science student, I have prepared this video. So anyhow, I have done what I can do. So anyhow, bye.